Hello guys! Now, I will show you how SRT or shortest remaining time works. But before we start, SRT is the process which has the shortest job will be executed first. In other words, if one process is being executed, then another process came, CPU will choose of those processes has the shortest remaining time. To better understand, I will show an example. We have here P1, P2, P3, P4, P5, and P6. We will use Gantt chart to better understand the concept. As we can see, at time 0, P1 arrives with a service time of 8. During the execution, at time 1, P2 arrives. Since this is preemptive, the execution is stopped and the CPU will check which process has the shortest remaining time. So now, we have two processes available, which are P1 and P2. The CPU has executed P1 for 1 unit. So the remaining time of P1 is 7. While the remaining time of P2 is 4. Therefore, P2 is scheduled since it has the shortest remaining time. While execution, P3 arrives at 2. So the execution is stopped. At this time, the remaining time of P2 is 3 because it has already executed for 1 unit. And the service time of P3 is 2. So the priority now is P3. Then P4 arrives at 3. So the remaining time of P3 is 1. The execution will stop and check which process has the least remaining time. At this point, P1 has the remaining time of 7. P2 has 3, and P3 has 1, and P4 has also 1. Since P3 and P4 are equal, the schedule will be according to arrival time. P3 arrives earlier than P4. Therefore, it will be scheduled again. Then at time 4, P5 arrives. At this time, P3 has completed the execution. So we will remove P3 in the list. The next process to be executed is P4 because it has only 1 remaining time. At time 5, P6 arrives. And this time, P4 has completed the execution. We only have 4 available processes now, which are P1 that has 7 remaining time, P2 has 3, P5 has 3, and P6 has 2. Since P6 has the shortest remaining time, P6 is scheduled. After that, P2 will follow. Next is P5, and last is P1. Now, we will compute the completion time. The completion time of P6 is 7 because 5 is the arrival time and 2 is the service time. Next is P2. The completion time of P6 is 7 plus the service time of P2 is 3. Therefore, the completion time of P2 is 10. Next, P5. The completion time of P2 is 10 and the service time of P5 is 3. Therefore, the completion time of P5 is 13. Lastly, 13 plus the service time of P1, which is 7, is equals to 20. This is the completion time of P1. For the turnaround time, we just need to subtract completion time and arrival time. For P1, 20 minus 0 is 20. For P2, 10 minus 1 is 9. For P3, 4 minus 2 is 2. For P4, 5 minus 3 is 2. For P5, 13 minus 4 is 9. And for P6, 7 minus 5 is 2. To get the average turnaround time, add all the turnaround time and divided it to 6. Since we have 6 processes, so 20 plus 9 plus 2 plus 2 plus 9 plus 2 is equals to 44. So 44 divided by 6 is 7.3. This is now the average turnaround time. Lastly, for the waiting time, subtract turnaround time and service time. For P1, 20 minus 8 is 12. For P2, 9 minus 4 is 5. For P3, 2 minus 2 is 0. For P4, 2 minus 1 is 1. For P5, 9 minus 3 is 6. For P6, 2 minus 2 is 0. To get the average waiting time, add the waiting time and divided it to 6. So, 12 plus 5 plus 0 plus 1 plus 6 plus 0 is equals to 24. So 24 divided by 6 is 4. This is now the average waiting time. And that's all for the shortest remaining time scheduling algorithm. Thank you.